good estimate? It was.
Yeah.
So in this exercise, our volume went up. So that happens when our pressure goes down. To what did the pressure drop?
0.94.
0.94? 0.94 atmospheres. Seems like you guys got a pretty good handle on this stuff. Okay. If you're feeling good about this this mathy stuff, give me a thumbs up. If you want to talk about it some more, wave your hand around. All right. Now, there is a third law called Gay-Lussac's. But, yeah. So, if you have volume and temperature equals a constant, and volume and pressure equals a constant, there is a formula that relates pressure and temperature to a constant. But you don't really need it. So if you put Boyle's law and Charles' law together, you get the combined law, which simply states the pressure, volume, and temperature conditions in one state will equal the pressure, volume, and temperature conditions in another state. P1, V1 equals, or T1 equals a constant equals P2, V2 over T2.
And not equal the same. They both equal the same.
That equals that. So if you happen to have all three things, pressure, volume, and temperature, those three, the product or the product and the quotient of those three will be a constant. So you can say P1, V1 over T1 equals P2, V2 over T2. Yay! This is called the combined gas law because we're combining them. Ready for a sample exercise?
Yeah.
All right. Consider this. A sample of gas at 2.3.
Sorry. My bad. I was stressed.
You're like, oh, I was checking my phone. You're stressful. You're
Yeah,
like,
your notes on my phone.
oh, okay. All right. A sample of gas at 2.3 atmospheres, 3.2 liters, and 310 Kelvin. What pressure will it exert at 4.1 Kelvin and 500, or sorry, 4.1 liters and 500 Kelvin? P1 over T1 equals P2 V2 over T2. Camera's catching all the audio. Wouldn't your parents want to love to listen to it? Now give your parents the YouTube link. Have them get online.
I need to go get a tissue.
This is my class. I'm sorry?
You shouldn't just like edit it. You should just put it like raw.
I don't edit it.
Oh, okay.
I don't edit anything. It takes too much time to edit everything. I just upload it all.
Will you upload all those videos on YouTube?
Why do you have a glove on?
Title it ASMR with Ken Rose.
I just want to figure it out. What did she say? Because I said title ASMR with Ken Rose. Look at that sample.
Check back in about 4 years.
Me?
It's not going anywhere on YouTube. It's going to be there, yeah. Check back in about 4 years. Hey, Mr. Byers, I went to college and my life has changed. I've become more mature. Great, let's watch those videos now.
It wants me always smart. Almost people in the front row with back row. Only the people in the first row with the
Now, it's a little more difficult to determine what the numbers should do because you might have pressure going up and temperature going down. You might have pressure going up and volume going up. So you do have to mathematically solve it, and then you need to check your work mathematically. To check your work, multiply whatever you get for P times your V over your T, and make sure they're the same things on both sides of the equations. If you don't check the work and you get this wrong, so on you. Always check your work. You should always check your work. So if you did the math, whatever algebraic mechanism you used, what is P2?
2.9.
2.9? 2.9? All right. 2.9 atmospheres? Make sense? Okay, so if you're trying to get P2 all by itself, what I would do is this. I would take your 2.3 atmospheres and your 3.2 liters over your 310 Kelvin. And I would multiply both sides by 500 Kelvin, because you want to get P2 all by itself. So we're going to put the 500 Kelvin up here, and you're going to divide by both sides by 410 liters. You're going to put the 410 liters back here. And that's going to get P2 all by itself.
Okay.
Cool? All right, questions? Cannon, can you press the silver button, please?
Have I subscribed to Canon?